What is up, guys? Fahir here from AwesomeTuts.com. Let us now import the assets for our new game that we are gonna create. As you can see, I have a brand new project. This is a 3D project, so when you create a new project, check the checkbox or the radio button for 3D. Name your project, save it in any location where you want to save it, and create it. Here I only have the scenes folder with my gameplay scene, which is this scene right here, which is completely empty. I did not import anything. I was waiting for you to watch this video. So now we're gonna go in our assets folder that you can download in the link below and select all of these assets. So we have fonts, materials, models, prefab sounds, and textures. So drag and drop them right here inside of the project tab. And of course, we will need to wait for Unity to take mercy upon us and import all of these assets. So let us wait one moment more. And finally, they are here. So in this video, I'm going to set up our main or gameplay scene, and we're gonna do that by going inside of the prefabs folder, and here we have our level, and here it is. I'm simply going to drag and drop it here in the hierarchy panel, and voila, this is our level. I'm just gonna go here with my mouse and see it, and this is our level. Now, of course, it looks like it's a little bit dark, but now it's a little bit white again. So I'm gonna go quickly inside of this lightning tab, and I'm gonna uncheck this auto generate. And the lightning tab is under window, and then here you will see lightning, and then you're gonna click on settings, which will open this tab right here. It will probably be floating for you. Let me try if I can make it float. No, apparently not. Here, yeah, finally. So it will probably not finally be floating for you like this. I dock it usually right next here to the inspector panel on my right side. And when you select the lightning tab, you're gonna go right here inside or the bottom of this lightning tab, and you're gonna uncheck this auto generate. Now this auto generate, notice here when I hover over, it says automatically generates lightning data in the scene when any changes are made to the lightning system. This means if we take this directional light and if I even change it a little bit, so if I change the rotation from 50 to 71, it will rebake lightning, it will try to simulate lightning, and that takes time. That's the reason why I have turned this off. It will try to rebuild the lightning settings, which will take a lot of time for us, and we will need to wait. Your computer will get hot, so on and so forth. That's why I am going to turn it off. Now, we are going to duplicate this directional light, but first of all, for this light, I'm gonna set the rotation to 10, like this. And it already looks pretty nice. And the intensity, I'm gonna set it at 1. We can set it at 1.5, for example. But 1 will do, and I'm going to duplicate it. So I'm gonna quickly duplicate it here. And this is directional light 1. And also for this one, I'm gonna set the rotation for the y-axis at 0. So the position X is 0, position Y is 3, Z rotation is 0, rotation X is 10, Y is 0, and Z is 0. This is for our directional light 1. For our directional light 2, so this one right here, I'm going to set the Y rotation at 43. And do we want to set here 0.3 for the intensity or something like this? Because now we're casting shadows here on the side. And of course, this all depends on the intensity. It depends on the lighting. I can also pump up the intensity, which will be something like this, which is something you use to kill vampires in your game. Anyways, I'm not gonna go too much into lightning because it is a separate topic on its own. I talk about this in the Ultimate Game Development Academy in a whole section with a brand project or brand new project. So a separate project for talking about lighting, demonstrating how lighting works. So it's a separate topic for itself. But here I've just used this directional light. I can actually remove this one so we can leave it at 1. You can play with the intensity if you want to, but I will leave it at 1. And the rotation is perfect. I have turned off the duplicate, by the way, and it looks nice. It looks pretty nice. If I go in the game, this is how it looks like. And by the way, for the main camera, here it is. The z-axis is going to be 0. The y-axis is going to be 1, something like this. And also the far for clipping planes, I'm going to set it at 10, something like this. This, what I did for the clipping planes, it will simply, if I pump it up, pay attention to these parts right here. Let me just demonstrate which parts do I mean. Come on, highlight tool, where it is, here it is. You see this from camera, this right here and this right here, like what the camera is seeing. So pay attention to that. If I take my clipping planes and place it far, it means it will see as long as the camera is stretching. You see, as long as the camera is stretching. We don't need that much. We only need 10 to stretch the camera right here where our plane is or our game field is. And this looks pretty nice. This looks pretty nice. I'm pretty satisfied with this. So we're not going to touch this anymore, but we are going to go and create our snake. And I am going to right click here and create an empty game object like this, 0, 0, 0. And this game object is going to be our snake. So I'm going to name it snake. Now, for our snake, we need to filter for our mesh, which is our eyeball mesh. And here it is, eyeball. I know I'm using an eyeball for our snake, but hey, nobody's perfect, so don't judge me. And I am simply going to take this eyeball and put it here inside of our game. And we already see it is casting shadows. Let me just clear this console. And here it is, this is our eyeball. I'm going to take this one, the child one. I'm going to remove this one, which is the parent one, and I'm going to put it as a child under our snake. And let me just position, so 0, 0, 0. For our rotation, I'm going to see here or set it -90, so -90, 0 for the Y, 180 for the Z. For our scale, 1, 1, and 1. And by the way, our snake here, we need to set the z-axis, let me just, 5.8, something like this, 5.8, so now it is visible. And for our eyeball, which is going to be the head of the snake, so here I'm going to say head, I'm going to set it to 0.12, 0.12, 0.12. And I'm going to set it to 0.12, but I'm setting the scale. I did not set what I'm going to set. I'm going to set the scale. So select it, and the scale is going to be 1.12, 1.12, 1.12. Now this is for the head of our snake. We are also going to duplicate the head, and I'm going to put it here. And this one is going to be our node one. I'm going to name node. And let me just move it right here. And this node, I'm going to say it's 0.1, 0.1, 0.1. It needs to be smaller than our head. And let me just duplicate it one more time. And I'm going to put one node as a child of our snake parent game object. And this node, I'm going to put it somewhere here, something like this. Now the other node, we can move it here. Let me just move it below. So let me just put this one a little bit closer to our snake. Yeah, this works pretty nice. And the last one is going to be our tail. So this is why I have removed this one, or this one is going to be our tail. And for the tail, I'm quickly going to add a sphere collider, and I'm going to attach a rigid body on it. So attach a sphere collider on this game object, this one that we named tail, and attach a rigid body on it. Now uncheck this use gravity because we don't want to use gravity, and duplicate it one more time. I'm going to rename it to simply tail and put one of these as a child of our snake. Now let me just zoom in, and for our tail here, I'm going to set it at 0, 0 and position it here, something like this. So we are going to position it to be as a tail of our snake. And for this one, we're going to save it in prefab. So I'm going to go here and create a folder that I'm going to call snake. And inside of the snake folder, I'm going to drag and drop this tail. And now we can safely remove it. So tail can be removed. And now this is our snake. If I go into gameplay scene, you see this is our snake. So the tail is here. It has a sphere collider and a rigid body. The node can also have, or it needs to have, a sphere collider, but we can uncheck it for this node. So for the second one, the one after the head, we don't need the sphere collider to be checked. And the rigid body, we are also going to add it and uncheck use gravity. By the way, for the tail, also make sure that you check this is trigger and do the same thing for this tail right here. Check it to be a trigger. The tail right here, I meant the one that we dragged and dropped into the snake prefabs folder. And for the snake's head, which is this dude right here. Now for this one, we are also going to attach a sphere collider. So sphere collider, make sure it is a trigger. And I am also going to attach a rigid body. And for this rigid body, I'm going to uncheck use gravity because we do not need to use gravity for the rigid body, which we will see later on. We will demonstrate that when we start moving because we are going to move from our code. And if we let gravity do the thing, it will pull us down, which is something that we don't want. Now for this sphere collider for the head, we can actually also uncheck it. So you can uncheck it because the top game object, the top parent, this one, the snake, it will have a sphere collider. And this sphere collider's radius is going to be 0.1, or actually it is going to be 1. And the center is going to be, let's see where it is. Just quickly, let me see where my sphere collider is. So here it is. Yeah, it is large. Actually, I need to resize a little bit more. Going here, moving our sphere collider. Yeah, something like this. I need to resize it more. Let's say 0.1, 0.12, just so that I can see where it is. You see this green line? This is where our sphere collider is. If I set it at 0, I think this is perfect. Yeah, 0.1 or 0.11 is where we want this sphere collider to be. I am going to make it a trigger. Yeah, I think this is okay. Let me just try to resize it a little bit so that I can see where it is. Radius. Yeah. 0.11 is for our radius of the sphere collider. I'm also going to click on add component and attach a rigid body on this dude right here. And I'm also going to uncheck this use gravity because we do not need it. We don't need it. And this is it. This is preparation for our game. We have the snake, we have the level. I'm gonna drag and drop the snake in the snake prefab folder. So for the snake, we have an empty parent top game object. We also have the head, which is this one right here, or this one right here, the top one or the largest part of the snake. We have the node. This one I just named node because it's the second body part of the snake. And we have the tail. So every next game object that we add, because you know when we eat our fruit, the game object or the snake will grow larger. It's the same as on old Nokia phones. When you use that snake and you ate more and more, the snake grows larger and larger. So all of those other objects that we're going to add, so larger and larger objects, are our tails. So the tail needs to be named like this so that we can differentiate it. We have the head, we attach sphere colliders on all of them. So the tail and the sphere collider for the tail needs to be checked. It needs to work because we can collide with the tail. You know, the snake can kill itself if it touches itself. So this is for the tail. For the node, it does not matter because we are not going to do that for the node, which is the next part after the head. Head here, it's also going to have a rigid body. All of these game objects have a rigid body except for the head and the node. The sphere collider must be turned off, or we can also remove it. And for the snake, we have the sphere collider, rigid body, which is the topmost game object. And this is preparation for our snake. Moving forward with our game, we have prepared our level. We added our snake. We added 2 directional lights. We turned one off. Now you can turn it back on or turn it off. This all depends on you, however you want to do it. You can also turn the first one or the second one off and probably pump up the intensity on the first one. However you want to do it, it's up to you. So I'm not gonna touch that. I will turn the second one on. So both of them are turned on. This is our snake in the middle of our screen, and we need to start moving the snake. In order to do that, we need to go in our project tab and right click and create a new folder. And this one is going to be our scripts folder. And inside of this one, right click, and I'm going to create here folder for helper scripts. Now for our helper scripts, the first script that we need to create is our script that's going to hold our tags. So I'm going to name it tags. And first of all, right click, create a C# script. You are gonna double click in and open it in Visual Studio, mount and develop, whichever one you are using. Now, since in our tags class, as you already know or assume, we will add tags and default variables that we are going to use throughout our game. So I took the liberty to copy them simply here. And now you can pause the video and simply paste them. But before you do that, I am going to explain what they are. Now here it's player direction, not direction without N. Anyways, the tags here will represent the tags. So we have the walls. So when we collide with them, we will check if the collision happened with a game object that has a tag wall. When we pick up a fruit, we will check that with the tag as well. So these are the tags for our game object. And here we can say tail with small t or AIL. I wrote it all caps. And for our metrics, so these are the metrics that we are going to use to position and move our nodes inside of our game, or to move the snake. We will see that. Do not worry about that. And this is a public enumeration to determine if we are moving left, up, right, down. And this is the count, e.g., or it will show us how many movements do we have. So 1, 2, 3, and 4. So we have 4 movements. Now, as you can see in our public enum, we can say left is equal to 0, up is equal to 1, right is equal to 2. So we can do that as well. This is something that we did not do before. So I am showing you that we can do it. And why are we doing it like this? Because later on we will use these values, so 0, 1, 2, and 3, to access indexes in our array. So don't worry about that. You can pause the video now and copy all of these tags, metrics, and player direction. And now I am assuming that you have copied all of those, and I'm gonna move forward and go in Unity, and in scripts, I'm going to right click and create a new C# or actual new folder. And this one is going to be our player scripts. And inside of this folder, I'm going to right click and create a C# script. Now this one is going to be our player controller. This is the dude who needs to be attached on our snake. So select the snake, drag and drop our player controller just like this. I'm going to double click it and open it here in Visual Studio. Let me just do my thing as always. And this is going to be the script that's going to move the player. We are going to create another separate script for getting input. That means we will move the snake or the player left, right, up and down. And for that, we'll use a separate script. This script is the one that is going to move the player. And of course, we need here a couple of variables. The first one is going to be our public player direction, which I'm going to simply call direction. And since it's public, it will be visible in the inspector panel. I am going to hide it in the inspector. We don't need it to be visible in the inspector panel, but we need it to be public. Next, we also need here, and hide in inspector, public float step length, which is going to be equal to 0.2f. Now this is the movement interval. So we are going to move our game objects or the snake by this movement interval, so 0.2. Now, we don't want to move our snakes every frame, that is 60 frames in a second. So we don't want to move it every frame. So we need a movement frequency. So here I'm going to say public float movement frequency like this, which is going to be equal to 0.1. And I'm also going to hide this bad boy in the inspector. Now, you see, we're going to move our snake every 0.1 of a second instead of moving it every single time or 60 times in a second. That's why we need this movement frequency. Now, we also need a private game object, which is going to be our node prefab, or actually our tail prefab. So you can name it tail, you can name it node, however you want it. It is private. It will be only accessible here, but we need to make it serializable or serialized field because we want to drag and drop our tail. If we go back here in Unity, and notice here in the inspector, we will see an empty field to drag and drop this game object and it is located in the prefabs and snake. Select here the snake and drag and drop the tail right here. I'm also going to hit apply to make changes to this prefab. Now, this is why we need to make it a serialized field, because we want it to be private, but still we need to drag and drop that game object inside. Now we also need to store the next position displacement based on player direction. And for that, we are going to use a private list of vector 3s, which we are going to call delta position. This is where we are going to store the previous movement of our player. Don't worry, we will see everything in action. We also need a private list of rigid bodies, which I'm going to call nodes, and this is going to be every single separate node inside of the snake's body. That is snake's head and snake's tails, so on and so forth. We also need a private vector 3, and for this one, fruit node. Actually, we don't need this one, so we are not going to use this one, but we are going to use a private rigid body for main body, a private rigid body for the head body, and a private transform TR for our own transform, so TR not transform. We also need a private float counter and a private bool move. Now this counter, we will use it with the movement frequency to allow the player to move, and we can put these two right here so that they are put with the appropriate or right below the appropriate variable that will accompany them later on. And the last variable that we need is a private bool create node at tail. This will tell us, do we need to create a node at our tail? That is when we eat a fruit. Do we need to create a node or not? Now, instead of me explaining all of these variables one by one, what they are, I will demonstrate that. So in the awake, so I'm going to change start to awake. In the awake, the first thing that we're going to do is we are going to say our TR is equal to our transform. TR is this one right here. So we're going to get it with our transform is equal to TR. Next thing, our main body is going to be equal to get component and get the rigid body component from our player. And that is the top head or the top main body of the snake. So the top parent, which is the empty game object. So this one right here that we currently have selected in the hierarchy. We have that one selected. That is the one that we are getting its rigid body by using get component. The next thing that we need to do is we need to call here init snake nodes. Now this is a function that we still did not create, and right below that function we are also going to call init player. And this is also a function that we still did not create. Now let us go and create that. Right below the update, we're going to create void init snake nodes. Now in this one, we are going to initialize the nodes. That means every single separate part of the snake. As you can see, if I go inside of the scene view, you see we need to get all of these nodes. So we need to get the head of the snake, so this one. We also need to get this node, the middle one, and the tail one. So we need to get all three of these. So here in our init snake nodes, we're going to say nodes, which is our array of rigid bodies, or a list you see here of rigid bodies. And we are going to make it a new list of rigid bodies. And below here, we're going to say nodes.add to add to that list. And we're going to say tr, which is our transform, get child. And we're going to get the child that's at the 0 index dot get component. So it's get component, rigid body component, just like this, close parentheses, and we're good to go. Copy, paste, and we're going to say child1 and child2 and what is going on here. Now, before I explain, the last thing that we need to do is our head body is equal to nodes and the element that's at index number 0. What is going on here? You see here we are using tr, which is our transform. You see here our tr is the transform, get child, and we are getting the child. What does this mean? You see our transform, the topmost transform from our snake, it has children. So we have the node or the head, the node, and the tail. And we know that, or the transform knows that we have children assigned to it. So we can use or access those children's by using indexes. So you can say get child 0, which means it will get the first child or the child that's at element 0, which is in our case head. Get child 1, in our case, it's the node. Get child 2, in our case, it is the tail. And here notice the head body, it is the rigid body of the head snake. So the rigid body of the head snake, and we know the head is set at index number 0, which I explained a moment ago. Now, in order to initialize our player, so right here below, we are going to create init player. Simply here, we are going to make sure where our player is moving, left, right, or up or down. So switch, so we're going to use switch, and we're going to use direction, and we are going to use cases in our switching case. So we're going to have case, player direction right, and here we're going to use break. I'm going to copy this and paste it. So we are going to have direction left, up, and down. And here I'm going to simply say down. So based on the direction, we are going to position all of our nodes or shift them to that position. So if we need to, or if our starting position is the right position, we are going to do this. So we are going to say nodes, and the element that's at index 1, that position is going to be equal to nodes, and the element that's at index 0 minus new vector 3. And here for our x, we are going to say metrics dot node and 0f 0f. And for our node number 2, or the element that's at number 2, and by the way, here we need to say node 0 dot position, so the position of our node 0. And by the way, inside of our nodes, we are adding rigid bodies. So when we say position, we are getting the position of the rigid body. You see here when I hover over, it says the position of the rigid body. So we're getting the position of the rigid body. And here we're going to say nodes, and the element that's at index 2 now, we're going to say that position is equal to, and we're going to use nodes and element that's at 0 dot position minus new vector 3. And for our metrics, so we are going to say metrics dot node, and we're going to multiply that by 2 and 0f 0f. What is going on? Well, when we start our game to the right, we need to shift the positions of our game objects to the right side. And in order to do that, we need to get the node 0, which is the head. What we need to do essentially, if we are starting to the right side, that means when we start our game, we will start moving to this side. What we need to do, we need to shift the position of this node over here and this node over here, because then we are going to move to the right, or actually to the left side. Excuse me, I'm moving to the left, but assume that I said left. So if we are moving to the left side, we shift their positions to the right side by using plus. Now, let me demonstrate that. So I'm going to move them back here. And notice here, if we are going to move to the left side, I'm simply going to copy these lines of code and paste them here. Instead of typing here minus, we're going to say plus. You see here, we are doing the same thing, except here we are doing that with the plus sign. So let me go back here and demonstrate that with the left position. If we need to start moving to the left position with our snake, that means we are going to this side. And we know that the head, so this bad boy over here, he needs to be at the top. So he needs to be the leading node in our snake. In order to do that, we need to shift this node over here. And we need to shift this node over here. And this is exactly what we're doing right here. So if we need to move to the left side, use the node that's at element 1 and use the element 0 node, which is the head, and add to its position the metrics node, which is the displacement. If we saw here, this is the displacement of our node. So this is how far away they are from each other. And do the same thing for our second node. Essentially, this code right here is going to position these nodes relative to the node 0, meaning, and let me just go back here, meaning our head is the relative position. So our node here, this code right here, is going to move this node over here. And this code right here is going to move this tail node over here. This is what we are doing essentially. Now we are going to do, or everything that we explained here for the left side applies to the right side, except, well, the right side is opposite to the left. For our up side, we are going to do the same thing except for the y-axis. So for the y side, we're going to say minus, but our metrics node is going to be on the y. So 0 for the 0f for x, and we are going to move that one on the y. And same thing here. So we're just going to take this and 0f for the x, and for the y, metrics node multiplied by 2. Why multiplied by 2? Because our node at second position is our tail node. So we need to multiply that by 2 because our head is here. Our node is here. We need to multiply this by 2. So 1, head is 1, node is 2, and multiply that by 2, moving that right over here. This is why we are multiplying with 2. For our down position, simply copy this code from the up position, paste it here, and for the down, we're going to say plus like this, and voila, we are good to go. Now, of course, we need to create one more function. So right here above our init player, we're going to create void set direction random. And here we are going to say int direction random, or dir random is going to be equal to random dot range from 0 up to, and we need to say here int, and we're going to say player direction dot count to convert the count to an integer, because if we use it like this without casting it to an integer and we go back in Unity, we will see here best of overloaded method match for random range float. We need to put this into a float or an integer, so I'm going to use it like this. Because our count, if you remember, has a value of 4, but this is an enumeration and we can cast this enumeration to an integer. I've talked this already once in one of my tutorials, can't remember which one, but anyways, we can cast it into an integer because, as I said, the value is 4. So the direction random will be based on random range, and notice here we are casting this value to an integer, and simply here we're going to say direction is going to be equal to dir random. Now, same way as we can cast these enums to an integer, we can use enumerations to cast integers to enums. So we can say here player direction. Now, based here on the random value, let's say random value is equal to 1. So this dir int or dir random value will have a value of 1. When we convert that into our enumeration player direction and we go back here, the value 1 is up. It will be the same if the value is 2. So value 2 is right. If the value is, let's say, 3, then the direction will be down. Now we do need to call this right here. So set direction random. We need to call it right above our switch and case statement. So we need to call it right there. And we need to go back here and we can uncomment, almost said unposition. We can uncomment these functions now. Now pay attention. If we go back here, I am going to clear the console and we go here in our game. Pay attention how the snake is positioned. Snake is positioned with right direction in mind. So it looks like it's going to start moving this direction. Notice now when we run the game, so I'm going to hit the play button. You see now it is positioned like it is going to go downwards, you see? And if I remove or stop the game and play it again, you see now it is positioned again to the right side. Stop and rerun the game. It will be positioned now, you see, like it is going upwards. So this is how we are moving these nodes relative to the head node. This is how are we positioning these nodes, by using these lines of code right here. Now we are still not done here with the awake function. We need to create our delta position, or which to go, or position in which where we are going. So our delta position is going to be equal to new list of vector 3s like this. Open, close these curly brackets, and here I'm going to pass a new vector 3, and here I'm going to say comma. Now for the x, I'm going to say negative step length, comma, 0f for the y. I'm going to copy this and paste it below. And here I'm going to say 0f first, so 0f. And here I am going to say step length, comma here. Paste this one right here. Now here we are going to have positive step length, and I'm going to copy this and paste it here. Now another comma here, remove this comma, and here we're going to have the negative length. Now right here I am going to add comments, and here we need to end this statement with our semicolon. So I'm going to add comments here like this. So this one is going to be our negative dx, or going to the left side. Here I'm going to put it like this. This one is going to be our dy, or going to the up direction. Right here I am going to say this one is going to be dx, or going to the right side, and this one, and let me just move all of these by one, and this one is going to be our negative dy, or this means going to the down direction. So you see here this step length, this one right here, is actually the value, or we are going to move by that value. So this is the time interval, that value. When we move, we will move by 0.2 units. This is what I'm trying to say. So when we have this right here, this means negative dy, we're going to the left side, or negative x, so to say. Here we have the positive y meaning up, here we have the positive x meaning right, and here we have the negative y going down. And you see here negative y, positive x, positive y, negative x. So this position right here means we are going to the left, up, right, and this one is going down. Now, in order for us to actually move, we need to create a function that is going to move us. But before that, we also need to create a function here. We need to create a function that is void check movement frequency. And for this function, we are going to say here our counter, so counter plus equals time.delta time. We know that time.delta time is the difference between every frame. So it's the time it takes from one frame to go to another frame. And we're going to say here, if our counter is greater or equal to movement frequency, what we are going to do, we are going to say our counter is equal to 0 to start counting from 0 again. And here we are going to say move is equal to true to allow our game object to move. Now, in order to make it move, we are going to say here void move, or create a function that is going to allow us to move, and not on animator move, no, simply void move. And inside of this function, we are going to create here a vector 3 d position. This is the delta position. We're going to use here delta position. So it's actually delta position. And we are going to use that by using here an int. and we are going to pass here the direction. So the delta position or D position is our delta position. We are casting the integer or direction to an integer to get it as an index. So depending on the index, if we are going to the left side, for example, if we're going to the left side, index will be 0, meaning we will access element that's at index 0 in the delta position. And if we go here, in the delta position, element that's at index 0 is left, as you can see right here. So now that we have our delta position, what is the next thing to do? First of all, we are going to create here a vector 3, parent POS, so parent position, head body dot position, and right below here we're going to create the vector 3 prev position or the previous position, and below here we are going to say main body dot position is equal to main body position plus D position. Right below we are going to say head body dot position is equal to head body dot position plus D position again. Now we are also going to move all the snake nodes. So we're going to say for int I, which is equal to 1, as long as 1 or I is less than nodes dot count, our I is going to be plus plus, and we are simply going to say here previous position is equal to nodes, element that's at index I dot position, storing the previous position, nodes, and element that's at index I dot position is equal to parent position, and parent position is now equal to previous position. Now don't worry if I'm not explaining everything in detail right now, because we will test it out soon, do not worry. After we do all of this, we need to check if we need to, not trigger, it's check if we need to create a new node because we ate a fruit. We will do that later on, and for that we're simply going to say if create node at tail, then we are going to write the code to do that for us. Now practically we are done for now, and we can test it out by going here. In the update function, we are going to call check movement frequency, which is this one right here. Come on, go down. This is check movement frequency. In the update, we're going to calculate our counter by adding to it delta time, and if the counter is greater or equal to movement frequency, then we will allow the movement. And in the fixed update right below here, so void fixed update, and let me just remove this private because I like it to be void simply. And in our fixed update, we're going to check if move, so if we can move, then move is equal to false, and we're going to call the function move. Not fog mode move, like this, thank you, like this. So, in the update function, we are checking for the frequency. So counter plus equals time dot delta time. If the counter is greater or equal to the movement frequency, then we are going to say counter is 0 so that we can count from the beginning, from 0. And move is equal to true. In the fixed update, if move is equal to true, move will be false and move the snake by 1 increment. And in the move here, this is where we are going to move the snake. Now, in order to test that and see it in action, I am going to go back here in Unity and run the game, and we're going to see the movement of the snake, and then we will go and break it down line by line. So when I hit the play button, pay attention to the snake. You see snake is moving by 1 increment. It is gone. We cannot control the snake. Notice now if I hit the play button, now snake is going downwards. Just a moment ago, first time when we tested out, snake was moving upwards. I'm going to hit the play button again. Hopefully it will move left or right. And now again it is moving down or up. Come on, try to move left or right just for once. Okay, now it is moving to the left side, and you can test it out as long as you don't see it moving left, right, up and down, but this definitely works. We see it now. Let me try one more time. Hopefully it will go to the right side. No. Anyways, let's go break it down line by line. So these here are now getting a clear picture, or we are understanding for what we're using this. Direction is going to determine in which direction our snake is going to go. Step length is the frequency or the units, measurement unit by how much units we are going to move every node. That is 0.2 units. Movement frequency is the how many times we can move in a second. So every 0.1 of a second we can move. Counter is used to test that out. So we are adding to our counter the delta time. We know that is it's a very small number. So the difference or the time it takes from one frame to go to another frame. So that's a very small number. And when that counter value is greater or equal to the movement frequency, which is this value right here, then we will allow our snake to move. So counter is reset back to 0 and move is equal to true. And moving forward, this is our tail prefab, which we will use later on when we eat a fruit or when the snake eats the fruit, we will add to the snake. So it gets larger and larger. This is the delta position, and you see here delta position is the direction where we are going. Is it left, is it up, right, or down? And we're using that by, well, using the step length and these values right here. You see here the negative step length is negative x, meaning we're going to the left side. Positive y, that means up, and positive step length, that means going to the right side. The negative y means we're going down. Now here are the nodes that we are going to get when we initialize the snake. Basically, these are the rigid bodies of every part of the snake. So the head, the node, and every part of the tail. So we can have 20 tails when we eat 20 fruits. Every single one of those tails is going to be added to this node array. You see here we're using the transform to get the childs. So we are getting the child at index 0, 1, and 2. Child at 0 index or at 0th index is our head. So we are doing or assigning that right here. And moving back here, we have the main body, head, and the transform. So the main body is our main body or the top parent or the parent of all game objects. So this one right here, the snake, that's the main body. Our TR is the transform. And here we are initializing the snake nodes by getting the rigid bodies from every child. Next, we are initializing the player. That means we are setting the direction, the initial direction of the movement of the snake. We're doing that with this function, which is this one right here. So you're using a random range from 0 and direction.count. So player direction count, we are casting that to an integer because the value here of the count is equal to 4. As you can see here, count is equal to 4. So when we cast it to an integer, it will display that value. So it will display 4, which means a random range from 0 or between 0 and 4. And when we get that random range, let's say that number is 3, we will cast it back to player direction. So if the value is 3 is down. If the value is, for example, 2, then 2 is right. And you get the picture. So we are assigning that to the direction. Now, when we do that in this function, based on which direction we have, is it right, left, up, or down, we will displace these nodes. And we saw that, we have previewed that. So let's say, for example, if the initial position is moving to the left side, if I hit here pause and I'm going to zoom in on our snake, I'm going to hit the play button. You see here, the initial direction was left side, which means both of these nodes, this one here and this one here, shifted to the right side by using these lines of code. So using the head position of our snake as orientation, and we're adding to that position this value here. Now metrics node is this one right here. This is the increment or the step length. This is the same as step length. And for our second node, we need to multiply that by 2 because we need to also place it after our middle node because we have 3 nodes. Same applies for right, up, and down. Now moving forward, here we have our check movement frequency. We have explained this. So we are adding to the counter delta time when the counter is greater or equal to the movement frequency. Reset counter, move is equal to true. This happens in the update function. In the move function, we are getting the delta position, meaning the direction where we are moving. So we are moving by using delta position, which is our array that we create right here. And we are casting to an integer the direction. If the direction is, for example, or the value of the direction is 2, that means we are moving to the right side. Next, we are getting the parent position, which is our head body position, and we are storing the previous position. Now, first we need to start moving the main body, which is the main body of our snake, the top parent holding all nodes. And we are going to move it by using or setting its position to be equal to its current position plus the delta position or the direction where we are going. So the direction position. We're doing the same thing with the head body. So head body's position is equal to head body's current position plus the direction where we are going. Now, depending on if we are going to the left, we are going to plus, and the value for the left, let me just see here. The value for the left is the negative step length and 0 for the y. So it will move it to that direction. Now we have to move all of our nodes. We moved our head already. That's why int I is equal to 1, because here, if you paid attention, the element or the first node is the node at element 0, which is our head node. And we already set the head body or the head node. We moved it. So now what we need to do is move all other nodes. That's why I starts at 1 and not at 0. And we are going to move how many nodes we have. If we have 100 nodes, then we are going to use count, which will be 100. So we'll move 100 nodes. Now the previous position, and we are getting that by using the node at the current I index in its current position. This is the previous position. The new position for that node is the parent position. So the parent position that we had here for our head. And now the parent position is equal to the previous position because the next node will be repositioned by using that same position. And the outcome for that is if we go in our Unity and if we hit the play button, you will see how our snake is moving. Come on, Unity, please have mercy upon us. So if I hit the play button again, you will see that the snake will move in the increment or using incremented values, or if we go here, the step length, that is, this is how many units it will use to move. So moving forward with our game, we have the snake moving and it is moving in a certain direction. The problem is that we cannot control that. We cannot control the movement of the snake when the game starts. So when we press any button, we will not change the direction of the snake. So in order to fix that, inside of our player scripts folder, we need to right click and create a new C# script, which we are going to call player input. And this script we need to attach on our snake right here. So drag and drop our player input. Hit apply so that this change applies to the prefab, and double click it and open it in Visual Studio. Man, I miss saying open it in MonoDevelop, but hey, people change, so now I'm using Visual Studio. I have changed. Anyways, moving forward, what do we need for our player input? The first thing is our player controller. So we need a private player controller that we are going to call player controller, of course. This is because we need to inform the player controller that we change the direction where the snake needs to move now. We are also going to create a private int horizontal, which by default is equal to 0, and vertical, which by default is equal to 0 as well. We also need to create a public enumeration, so public enum, that I'm going to call axes. And you can assume which axes do we have. So we have horizontal and we have vertical because, well, we have two axes. Now, inside of our start function, we can get our player controller. So player controller is equal to get component. So get component, player controller component like this. And this can be done in the awake function as well. So you can choose to put this into awake if you want to. We can leave it at awake because we are only getting here our player controller, because I like to initialize my variables in the awake function more than I like to initialize them in the start function. Now, inside of the update, the first thing that we need to do is that we need to get our player input. But before that, we need to say horizontal is equal to 0 and vertical is equal to 0 to reset their values. And now in order to get that input, we need to call a function that we did not create, and I'm going to call it get keyboard input like this. And right below here, we're going to create it by typing void in the name of the function, which is get keyboard input. And now inside of our keyboard input, we are simply going to say horizontal is equal to, and we need to say input dot get axis raw, and here we are going to say horizontal. And for our vertical, we are going to say vertical is equal to input dot get axis raw, and it is going to be vertical, but we have an error. What is this error? If I hover over, it says cannot implicitly convert type float to an integer. The problem is that this returns a float. You see this right here, this input get axis raw returns a float. So we need to cast it to an integer by typing in parentheses int in front of it, and the same thing we need to do it right here. So we are casting or converting this float into an integer. So we have here our horizontal and vertical. We do need to test if our horizontal is not equal to null, then we need to say our vertical. So vertical is going to be equal to 0 like this. And why did we type this here? Well, if we move horizontal, we need to set vertical at 0, and this is to prevent double movement. So just to prevent double movement, this is why we are doing it like this. Now, in order to test this out, we need to create a function that we, well, still did not create. And this function, let me just type this out here. I remove this curly bracket. Now, right below our get keyboard input, we need to create void set movement. And inside of our set movement, we are going to move our game object, but we are going to do it or call it right here, right below our get keyboard input. Now, inside of our set movement, here we are going to say if our vertical is not equal to 0, then we are going to call our player controller to change the movement. But in order to change that movement, we need to go here in our player controller. Right below our check movement frequency, we need to create a public void set input direction, which takes a player direction dir as a parameter. Now, first of all, in this function, we need to prevent movement in the opposite direction. What does that mean? It means that if we are moving up, we cannot start moving down. We cannot start moving down. Or if we are moving left, we cannot start to move to the right side, and vice versa. So we need to say here if our dir is equal to player direction up and our direction is equal to player direction down, or if our dir is equal to player direction dot down and our direction is equal to player direction up. You see my point? Because we cannot move in the opposite side. Because if let me quickly go here in Unity, and if I take my snake in the scene, let's assume snake is moving in the right side like this. We cannot press left and it will start moving left. No, we cannot do that. We need to start moving up and then move left, or down and then move left. This is my point. That's why we are testing this. And we need to say here as well if dir is equal to player direction dot right and direction is equal to player direction dot left, or if dir is equal to player direction dot left and direction is equal to player direction right. So if this is true, if some of these is true, then we're going to hit return, not a rect transform or whatever that was. If one of these is true, and notice we are using or, so only one of these needs to be true. So if direction is equal to, or dir is equal to up, and dir is the parameter. So if dir is equal to up and direction is equal to down, then that is true. We cannot move to the opposite side. Same thing goes for down and up. right and left, left and right. But if this right here is not true, then we are simply going to say direction is equal to dir. Now direction is our own variable that we are using here. Let me just find it. Here it is, our direction. We talked about it in the previous video. So direction is equal to the parameter that we put here. Now we also need to force move. So we need to say here, force move our game object or our snake. Now our force move, we're going to create it. So force move. And simply in our force move, we are going to say counter is equal to 0, move is equal to false, and move call our function to move the snake immediately without waiting for the next movement frequency threshold. Why? Well, because when we press a button, we want to move the snake right away. We don't want to wait for the movement frequency threshold to kick in so that we can actually start moving the snake. So right away when we press the button, and this is what we are doing here, so we are resetting the counter, move is equal to false, and we will call move to move the snake right away. Now, going back to our set movement, now if our vertical is not equal to 0, we are going to say player controller dot set input direction, and here we are going to test if our vertical is equal to 1, question mark, then we're going to say player direction dot up, colon, player direction dot down. What are we doing here? What is going on? Well, you see here, we are testing if vertical is equal to null. This essentially, this code right here, and let me just take this code. So this code right here that we did, and let me just put it right here so that we can actually see it. This is what we are doing. Pay attention here. So if our vertical is equal to 1 and we are using or questioning that or asking that with a question mark. So if it's equal to 1 and that is true, then the value will be up. Otherwise, the value will be down. This is essentially as if we are doing this. Let me just put it like this. And this is essentially same as if we typed if vertical is equal to 1, then our player direction is equal to player direction up. So player direction up. Else, if vertical is not equal to 1, then player direction dot down. This is what we are asking with this right here. So if the vertical's value is equal to 1, then we will set direction up, which is logical because vertical, that means that we will go upwards on the y-axis. If, and let me just go back, why is it taking me over there? Anyways, otherwise, if our vertical is not equal to 1, for this we are using this colon. So if it's not equal to 1, and let me just go back here. So if it's not equal to 1, that means that we will use direction down for the value, meaning we will go down. Now here we are going to say else if our horizontal is not equal to 0, we're going to do the same thing. So we're going to say player controller dot set input direction. And here we're going to say horizontal, is it equal to 1, question mark. And right here, we're going to say player direction dot right, colon, player direction dot left. It's the same thing except for our horizontal. So it's exactly the same thing. Now we can test this out, but we will have one problem and we will see what that problem is. So if I go back here, I am going to clear the console and I'm going to hit the play button. And notice now we can change the direction. See, we can change the direction, but you see the snake is moving like crazy as long as if we are holding our mouse or actually our keyboard. I'm pressing W key, ASD, or left arrow, right arrow up. You see the snake is moving like crazy, like some crazy parasite that came from out of Earth, you know, alien parasite, and it's trying to get into you. Now we don't want this. We don't want this kind of movement. We have this movement because we are using input get access raw. Now this is not something that we want, so I'm going to comment this out. We need to create another function that will get us the movement of the snake. Now here we're going to create a function that will return an integer, and we're going to call it getAxisRaw, which takes an axis, and I'm going to call it axis as a parameter. And it takes this axis that we created, this enumeration right here. Now, right at the bottom of this function, we are going to return 0 if nothing happens, because we need to return an integer. But what we are going to do here is that we are going to test if our axis is equal to axis.horizontal. So we need to check for the horizontal axis. Then we're going to say bool left is equal to input.getKeyDown. Did we press a key down? And that is going to be keycode dot left arrow. And bool right is going to be input.getKeyDown, and this is going to be keycode dot right arrow, like this. So we are going to get here the boolean for the left and the right. Now you can do the same thing for our WASD. I'm using here arrows, so pay attention because we will use arrows, left arrow, right, up and down arrow on your keyboard to move our snake. Now you can do the same thing for W key, ASD, and to move that snake with those keys. So here I'm going to say if left, meaning if we pressed the left arrow key, then here we are going to say return -1 because we are moving to the left side. If right, then we press the right arrow key, we're going to say return 1 like this. Otherwise, we are going to say return null like this. Else if our axis is equal to axis.vertical, so we need to check for the vertical axis. Then we're going to say bool up is equal to input.getKeyDown, and we are testing for key code. So getKeyDown, and it's keycode dot up arrow. Our bool down is equal to input.getKeyDown and keycode dot down arrow. And same thing. So we need to test it like this. So we need to say here if up. So if up, we pressed the up arrow key, we are going to return 1. If down, then we are going to return -1. So return -1. Otherwise, return 0 or return null. I'm saying null for 0, but actually it's return 0. So this is what we are doing, and let's go inside of our keyboard input, and right here our horizontal is going to be equal to getAxisRaw, passing here axis.horizontal. Our vertical is going to be equal to getAxisRaw, passing our axis.vertical. So it's vertical like this. Voila! So if we go back now in our Unity, and if I press the play button, and notice now if I try to move, you see the snake, I'm holding the up button, so I'm holding these buttons that I'm pressing for the snake to move. But the snake is not moving like crazy like it did a moment ago. And notice here, pay attention now, you see the snake is moving, and let me just go and demonstrate this. So in our player controller, if I uncomment or actually comment these lines of code out, you will see how this helps us preventing the snake's movement. So pay attention now. If the snake is moving, you see now we cannot move it like this. You see it's moving to the left, and now we're changing it to move it to the right, or now down, and now it's moving up. You see, we cannot move it like this. We cannot move the snake like this, because the snake then will hit itself and it will die. Because remember, if the snake, or in the snake game on old Nokia phones or any snake game, when the snake hits its own tail, it is dead, gone, kaput, bam, wow, however you want to call it. Anyways, it is dead. The game is over. So that's why we are preventing the movement in the opposite direction, because now if I am moving, for example, to the left side, I cannot press right to move. So I'm moving to the right and I'm pressing left, it's not working. I'm moving to the left, pressing right, or moving up, pressing down, it is not working. We need to turn left or right, and then move to that side where we want to move. And also, let's go and briefly break down all of these codes. Now, this right here, it's pretty clear. This is clear what it is. This right here as well. Here we are resetting horizontal and vertical every time after the input. And here we're getting that input. Now, pay attention here, we are using horizontal and our function get axis raw, and here get axis raw. Here horizontal, here vertical. This is clear as well. So here, when it's horizontal, we are checking for get key down. If we press our key code down, for the left arrow or the right arrow, we will store that in these booleans. If we pressed left or if we pressed right, we will return -1 or 1, depending on which one of these we have pressed. Otherwise, we will simply return 0. Same thing for the vertical axis. If we press key code up or down, this will trigger, or it will set the appropriate boolean out of these two to be true. If we press up, we will return 1. If we press down, we will return -1. Because down on the y-axis is negative, up is positive. On the left side for the horizontal, left is negative, right is positive. We did this probably thousands of times in my tutorials on YouTube channel, in the Ultimate Game Development Academy. And I talked about this thousands of times, and this is basic math. If you go to the left side on axis, it is the negative side. Right side is the positive, up is positive, down is negative. So moving back inside of our get keyboard input, we are storing that value in the horizontal, so it will be either 1 or -1 or 0. And here we are checking if our value is not equal to 0. So we need to check if it's not equal to 0, because if it's equal to 0, we are not moving. So we are not moving if it's equal to 0. So if it's not equal to 0, it's either 1 or -1. If vertical is equal to 1, then we will set it up, which means positive. If it's not equal to 1, meaning it's -1, then it's down. Same thing for the horizontal. And in our player controller, we created set input direction. We are preventing here movement to the opposite side, and we tested this out a moment ago. And when that happens, we're setting the direction to our own, or dir, this parameter, to our own movement direction, and then force move the snake just so that it moves right away instead of waiting for the threshold of the movement frequency. Moving forward with our snake, we can move it and we can control it. So let us now detect collision on the walls and also add our collectibles. Now, first of all, we're going to start with our walls. And if we go here in the level, we have these walls right here. So all of these walls, and let me select all of them. So we have top walls, we have bottom walls, left and right walls. Select all of these walls except don't select their parents. So bottom walls, this one right here, left walls and right walls. We don't need to select these. So select all of the walls except for their parents. As you can see, I did not select top walls game object, bottom walls, left walls and right walls, because we are using that as a parent to store all of these children. So now when we have all of these, we are simply going to click on add component, and we are going to add a mesh collider. So mesh collider component on all of these so that we can detect collision on them. And I am going to tag them. So click here on add tag, and I'm going to create a wall tag. I'm also going to create a fruit tag and a bomb tag. So select again all of these walls except for their parents. So select them except the parents and tag them with the wall tag. And voila, we are good to go. And also for these obstacles here, which are these, as you can see, so these right here, if I turn them off, so these, also set their tag to be wall. And I'm going to select the level and hit apply so that this change applies to the prefab. And if we go inside of our player controller and right here inside of our void on trigger enter, in our on trigger enter, we can test if we collided with the wall, except here for other, I'm going to say target, because I like to name this parameter target. And I'm going to say if our target.tag is equal to tags.wall, we are simply going to print here. So print touched wall, like this. So we touch the wall, and that is that. This is just for testing purposes. We will fix this later on. Do not worry about that. So if I go back here in Unity, and if I try to collide with some of these wall obstacles, pay attention in the console. So now when I hit one of these, bam, we should see inside of our console that we have collided with the wall. Now, of course, we collided with the top walls, but we're not colliding with the obstacle walls. That is because we need to select them as well and attach a mesh collider on them. We forgot to do that. So if I hit the play button again, and if I go through these walls that are obstacle walls, bam, you see touched wall, touched wall, touched wall when we go through all of these. So this is working. We are detecting collision between our walls. And now, moving back in our project, we are going to import the bomb and the fruit. Now here I'm going to filter for the eyeball in our project and drag and drop the eyeball right here. And I'm going to filter for the bomb, and I'm going to drag and drop the bomb also in our hierarchy panel. And inside of our prefabs, I'm going to right click and create a folder, and this is going to be our pickups. So pickups, where we are going to store the eyeball and the bomb. And here actually I'm going to name the eyeball to fruit and bomb ball simply to bomb. I'm going to tag the fruit with the fruit tag and bomb with the bomb tag. I am also going to remove the animation from the bomb, and for the fruit, remove the animation as well. I am going to change the scale of the fruit to 0.1, 0.1, 0.1. The z-axis is going to be 5.8, and we are going to attach a sphere collider on it. And actually, let me just take this fruit. So eyeball this fruit right here, and I'm going to name this game object here as fruit, and this one I'm going to say 0.1, 0.1, 0.1. Rotation, I'm going to say 0. This rotation, -90. And on this one, I'm going to attach a sphere collider, make it a trigger. And let me just see where it is. Here it is. This is our eyeball, or our fruit that we're going to use as a fruit, that is. And I'm going to tag it here with the fruit tag. Come on, select it, where it is. Fruit, not bomb. What is wrong with me? So tag it with the fruit tag. And for the bomb, I'm also going to change that. So I'm going to say 0.2, 0.2, 0.2. The Z position 5.8 for the bomb. And here is our bomb. We are also going to attach a sphere collider on the bomb. And voila, this is it. So if we go inside of our prefabs and pickups, I'm going to drag and drop the fruit. And I'm going to drag and drop the bomb prefab. If we go back in Unity here, if we touch the wall, I'm also going to say, or if our target.tag is equal to tags. So tags, come on, tags.bomb. We are also going to print now touched bomb, because we're going to check if we touch the bomb. Now for our fruit, we are going to do the same thing. So we're going to say if our target.tag is equal to tags.fruit tag, and here we are simply going to deactivate it. So we're going to say target.gameObject set active is false, and we need to say create node at tail is now equal to true, because remember here we are going to create a tail because we picked up a fruit, so we need to create a tail. Now first of all, we are going to test if this actually works, and then we will see how can we create that tail. So first of all, we are going to pick up the bomb and see if we are printing in the console that we are picking or picked up the bomb. So bam, we touched the bomb. That is good. We will end the game when we touch the bomb. Now we are going to pick up the fruit, and when we pick it up, bam, it is gone. But we need to create a node at tail, or make the snake larger, because we picked up a fruit. So if I go back here in Visual Studio, This now is true. Create node at tail is now true. So when we go back here, this is where we need to create that. So first of all, when this is true, we are going to say create node at tail is now equal to false, because we only want to create node at tail once. We don't want to create it multiple times. And if we continue, what is the next thing to do is that we need to create a game object. So we need to say game object, and we need to say new node is equal to instantiate, and we are going to instantiate the node prefab or tail prefab, and we can say here new tail or new node, actually new node tail prefab, and we are going to instantiate it where we are going to instantiate it using nodes, and we're going to say nodes.count -1 dot position, so position dot quaternion identity like this. And let me just move quaternion identity here. What are we doing here? We know that in our instantiate, we need to pass a game object that we want to instantiate or create a copy out of that game object. We need to pass a position, and we need to pass a rotation. Rotation is not important. Quaternion identity 0, 0, 0. What's important is the position. Notice here I'm using nodes and nodes count -1 dot position. This is the last node in the nodes array that we are storing here. And remember, in the beginning we stored 3 nodes, our head, our middle node, and our tail. And I said every new tail node will be stored inside of this nodes array, because we need to keep track how many do we have. And if I go back here, what is the next thing to do? We need to say new node dot transform dot set parent, and we need to set our own transform, and here we're going to say true. You see here world position, if world position stays true, the parent relative position, scale, and rotation are modified such that the object keeps the same world space position, rotation, and scale as before. So when we say here true, it will simply make this node keep the same position, same scale, and everything relative to its parent. And here we're simply going to say nodes add, and we are going to append to it new node dot get component, and we're going to append the rigid body component like this, because I said we are going to add every new node inside of this array. Now we can see this, the best way to see this is if I copy and paste a little bit or multiple of these fruits. So we can have one fruit here. I'm going to duplicate it, one fruit here, one fruit here, for example, one fruit here, and one fruit here, just so that we can see that our snake is growing larger. So now we have 3 of our snakes, so 3 parts of our snakes. Now we should have 4, you see? Now we have 4 and 5, you see? The snake is bigger. And notice now, again, picking up these, you see? The snake gets bigger and bigger. Again, picking one more, the snake is bigger and bigger. We picked up all of these, you see? We picked up all of these nodes. And you can see that every single one of those nodes, or actually those fruits, are being appended at the end of the snake, because we are using nodes and nodes count. We are getting the element that's at the count -1, which is the last element inside of that array. So the last element inside of that array, we are getting that, and we are positioning that node at that position. So if the last node, let's say, if I highlight or use my highlight tool, so this is the head of the snake, this is the node, this is the tail, and this is another tail. So let's say we eat a new node or new fruit here. So we eat it, nom nom nom. And now we want to append it to the snake. So the snake's position, or the snake grows larger. So this node needs to go here. That's why we are using this right here, nodes count. So this right here, position, which is the last position, count -1. It's the last element in the array, which is this one, and its position. So we are using its position to set it. So append that right here. So append it right after that position. This is what we are doing. And basically that is that. What we can also add here is that now we can say if, So here we can say, or if our target.tag is equal to tags.tail tag. So if we touch our tail, so you're also going to say print snake touched tail. And if I go back here, we need to make sure that our snake's last part has a tail. You see here, it needs to have a tail tag. So add tag, and here we are going to say tail tag. So select it, and this one will have a tail tag. Hit apply. And if we go back here for our snake, if I select it and the tail that we add here, this tail also needs to have the tail tag because the snake will die if it hits itself. And notice if I pick up some of these fruits and when we pick it up, the snake will get larger and larger, so then we can touch our own tail. Notice now we touch our own tail. You see here snake touch, and I spell touch with touche. So snake touched tail. You see we touched tail and bam, we should die when we touch our tail, but we will do that later on. Don't worry about that. The point is that this all is working. We can remove all of these fruits. So let me select all of these fruits. We can remove them. We are only left to create our gameplay controller who is going to spawn all of these fruits in our level, so on and so forth, and also create audio effects. But before we end this video, I'm also going to create our UI quickly because our UI is not going to be that large. So if I go here in our game, our canvas is going to be set on screen space overlay. I'm going to scale it with screen size 180 by 720, and I'm going to match the width and height equally. I'm going to take the image. This is going to be our icon, so snake icon, and I'm going to set the anchor at the top middle. I am going to set here for the source image this snake portrait, or however we are going to call it. The width and height is 80-80 for this snake. The position X is -99 and the position Y is -58, like this. And the next thing, we are going to add our separator. So I'm going to take here, I'm going to actually rename this one as well, UI canvas. I'm going to hit here, right click, and UI text. Now, this text is not going to be a child of our snake icon. It is going to be a regular text. I'm going to call it separator, and I'm going to simply add this line to separate, and we will see what we will separate. I'm going to set the font at Arial, and let me just resize it. I'm going to set the anchor at the top middle. The width is 29, and the height will be 135. The position X will be -32 and the position Y is -49. The scale or the font size is 103, and I am going to set the color to white, and voila, this is it. And actually we can move it just a little bit down, something like this. Yeah, this can do. So -62 can do, and voila, this is our separator. Now, I named it separator, it's separator. And we're also going to create a score. So here, instead of separator, I'm going to call it score. Now for the score, top anchor, the width is going to be 303. The height is going to be 83. The position X is going to be 151. And the position Y is going to be -60. And here I'm simply going to say score like this, 0. And let me just find it where it is. So where is my score? Where did I put it? Yeah, here it is. Here is my score. And let me just resize the font, something like this. So the font can be 50 here. In this case, I'm going to set the font at 50 and maybe just move the score a little bit down. -72. So -72 for our score. Now the font for our score is going to be our Open Sans Regular. Open Sans Regular, here it is. And voila, that is practically that. This is going to be our score, or maybe just move it a little bit up. So -69, this works perfectly. So this is our UI. Here is where we are going to keep track of the score. This is our snake image. This is the separator between the snake image and the score. Not that fancy because the point is not to create fancy UI. The point is to create our snake game. Also make sure that you attached or dragged and dropped the bomb inside of our pickups. So drag and drop the bomb and the fruit to make them prefabs. Let us wrap things up, starting with our gameplay controller. So in the scripts folder and helper scripts, I am going to right click and create our gameplay controller like this. And I am going to right click here in the hierarchy and create an empty game object, which I'm going to name gameplay. So it's gameplay controller. So gameplay controller. And I'm going to attach the script on the gameplay controller. What do we need? Well, as always, we need a couple of variables to start with. And let me do my thing. So let me tag the class, give a little bit of space. The first thing, we are going to make our gameplay controller an instance. So public static gameplay controller instance like this. And for our instance, right here, instead of our update, I'm going to create make instance. And inside of this one, I'm simply going to say if instance is equal to null, meaning it's not pointing anywhere, I'm going to say instance is equal to this, and voila, we are good to go. I'm also going to call this function in the awake function as always. So this is nothing new. We did this probably thousands of times so far. Before moving forward, I am also going to type here using UnityEngine.ui because we need to get ourselves a reference to the text displaying the score to our user, and we are going to display the score every time our snake eats a fruit. So here we also need a public game object for our fruit pick up. Now this is not a pickup truck, it's simply a fruit. And we also have a bomb pick up like this. Now also we are going to have a private float. This is going to be our minimum underscore x, which is equal to -4.25f. We are also going to have maximum x, which is equal to 4.25f. Now the minimum is negative and the positive or the maximum is positive. Minimum y, which is equal to -2.26f, and positive or maximum y, which is equal to 2.26f. And also our private float z underscore pos, which is equal to 5.8f. What is all of this here? What did I just type? Am I going crazy or not? Well, first of all, we need to make sure that we are going to spawn our fruits and the bomb between our game objects here. Let me just find the level. Here it is. So when I said between our game objects, I meant between here and here. So as you can see, this point, let me just take it again. So this point here is let me just find it. It's -4.25. So -4.25, which is somewhere around here. And this one is +4.25, which is somewhere around here. How did I find these values? Well, I just did as you just saw. I took this fruit or this eye and I positioned it here and saw which position that was, then positioned it here and saw which position that was. Did the same thing for y-axis. And voila, this is how I got them. Now our fruit and bomb in the scene, we can remove them because we're going to drag and drop. If I select the gameplay controller, we will go in prefabs and pickups, and we will drag and drop these from our prefab. So fruit pickup will go here and bomb pickup will go right here. So moving forward or going back here, and Z position is same as for all of our game objects. You can see snake has Z position 5.8. So does every other game object that we want it to be visible. So moving forward, we also need a private text, which is going to be our score text. And we need a private int, which is our score count. Now, inside of the start function, we are going to say, so void start. And here we are going to say our score text is equal to game object. Find the game object with the name score, get the component text from that game object like this, and we are good to go. Now you need to make sure that the name of that game object is indeed score. So in our UI here, so UI canvas, here it is, score. So make sure the names match up or otherwise this will not work. Now we are going to create functions that are going to start spawning our pickups, be that a bomb or our fruit. So first of all, we are going to create an enumerator, a coroutine, as you might assumed, and we are going to call it spawn pickups like this. So start spawning pickups, and here we're going to say yield return new wait for seconds, and we are going to wait from random dot range between 1f and 1.5f. So between 1 second and 1.5 of a second, we're going to wait, and then we will spawn either a fruit or a bomb. And we're going to do that using a random value. So if random range from 0 to 10 is greater or equal to 2, then we are going to instantiate a fruit. So here we're going to say instantiate, and we're going to pass here our fruit pickup at the position new vector 3 like this. And for our x, we're going to say random dot range from minimum x to maximum x. This is for the x position. For the y position, random dot range from maximum or minimum y to maximum y, and our z position, so ZPOS, comma, quaternion identity, and we are good to go. So let me just put quaternion identity right below here, and voila, we are good to go. This is for spawning our, and actually I'm also gonna put new vector 3 right here and put this right here. So it works perfectly, like a charm. So instantiate the fruit pickup on the random range between minimum x and the maximum x, minimum y and the maximum y, and I've explained this. It will instantiate our game objects. So I'm going to take it like this and zoom in on our level just a little bit, something like this. And I'm going to take the highlight tool just so that I can demonstrate that. This is the minimum x and this is the maximum x value, minimum or maximum y, and this is the minimum y. So between random range between minimum and maximum, that's this range. So between here, so between these two values here, it will spawn it on the x-axis, and on the y-axis, it will spawn them between these values. As I explained a moment ago, how are we instantiating, or how did I get those random values? So this is if random range is greater or equal to 2, because there is only 20% chance that we will spawn a bomb. If that happens, then here we are going to copy this line of code, and here in the else statement, instead of fruit pickup, we're simply going to say bomb pickup, and voila, that is that. But we need 2 more functions, because here above, we are going to create void start spawning, like this, so start spawning. And here we're simply going to say start coroutine, and we're going to start our spawn pickups coroutine, which will start, well, this coroutine. But here inside of this coroutine, we are also going to call invoke, and we are going to invoke this function like this. So you see here, we are invoking this function, this one right here, that will call our coroutine, and again, over and over and over and over until we create here a public void cancel spawning. And in our cancel spawning, we are simply going to cancel, so cancel invoke, passing here the start spawning invoke coroutine that, well, we are going to cancel. And when we start our game right here in the start function, we are going to spawn it after 0.5 seconds, so 0.5 of a second, and we will start spawning and spawning and spawning. Now, before we test this out and see if this actually works, and it will work, we are going to go here And we're going to create a public void increase, so increase score. And here simply we're going to say score count plus plus, and our score text dot text is equal to score colon plus score count. And this right here will be called inside of our snake. So when we go in our player controller, when we pick up a fruit, you see here, we are going to call our gameplay controller. So gameplay controller dot instance dot increase score. Just like that. So simply call it to increase the score. And by the way, notice here, if I go and run our game, I'm going to hit the play button. So now after 0.5 of a second, you see here, we have a bomb, we have a fruit. So here I'm going to pick up a fruit, another bomb, fruit right here. Let me try to pick it up. So fruit here. Now, one thing that you are probably noticing is that these game objects are staying in the scene. They are not being deactivated until we pick them up or until we touch the bomb. And eventually we will run out of places where we can walk or move because of the bomb. Now, because of that, we need to go in our scripts. And here I'm going to create a new folder for our pickup scripts, and simply here I'm going to create deactivate pickup. So C# script deactivate pickup. Inside of this script we are simply going to create two functions, or actually one function called void deactivate, which is going to do what? Game object set active, so that set, not gameplay controller, game object, and this is what I hate. So Visual Studio crashed on me for some reason, so we need to wait for it to reload again. When this happens, I simply close Visual Studio. This happens also with MonoDevelop. I hate it when this happens. It simply freezes. It will not take into consideration mono behavior, mono develop, whatever, but now it works because now you see I can call our game object set active is false, and in the start I am going to invoke our deactivate after random range, so random.range between 3 seconds and 6 seconds. So between 3 seconds and 6 seconds we are going to deactivate our game objects. Now, as we did, or did we go here in our gameplay controller and we called here increase score? Actually, I did not even test that out. I did not see. We were looking at our fruits, but pay attention now. So pay attention to the score when you start picking out fruit. You see score is now 1. And let us try to pick this up, and now score is 2. And again, our fruits and our bombs are not being deactivated because, silly me, select them right here in the prefabs and attach the deactivate pickup script. So if I hit the play button now, and pay attention to the score again, so when we start picking up fruits, we will start also counting the score. So now score is 1, score is 2, and you see the fruits are disappearing. I almost caught that one, or did I cut this one? I think I did. Okay, this one I missed. 4, okay, this one I missed. 5, and you see, it is working. So we are counting the score, everything is going perfectly well. What we need to do now is actually stop the game when we hit one of these. So either wall, bomb, or tail. So when we hit one of these, we simply, what we are going to do is we are going to say time, not tone, but time scale is 0. We are going to stop our game. Then you can restart the game by using your code, or either press the button and restart it, because I'm not gonna go. We did this already numerous of times, restarting the game. We created menus. I do this extensively in the Ultimate Game Development Academy, so you have all of the resources you need to create your own mechanism for restarting the game, so on and so forth. Because what I'm going to do now is go in Unity, and I'm going to hit here or double click and create an audio manager script. And going back in our scripts folder and helper scripts, right click, I am going to create a C# script, which I'm going to call audio manager. and attach it on the audio manager game object. So simply drag and drop it on the audio manager. And what do we have in our audio manager? Well, first of all, let me just tag the class, give a little bit of space. We are also going to make him an instance. So we are going to say here public static audio manager instance like this. And here we are simply going to create void make instance. So if instance is equal to null, we're simply going to say instance is equal to this. In our awake function, we're going to call make instance, and that is that. This is for our instance. And we're also going to have our public audio clip for our pick up sound and for our dead sound. And for these two, we are simply going to have a public void play. Why are you correcting me? So public void play underscore pick up sound like this. And we are going to call here audio source play clip at point. The clip is pick up sound at point transform dot position. And I'm going to duplicate it, paste it here. This is going to be play dead sound. And simply here instead of the pickup sound, we are going to paste our dead sound. And it's simple like that. And for our sounds, go in the audio manager. And for our pickup, so pickup sound is going to be our eat fruit sound. And for our dead sound, we are going to have game over sound 2. So game over sound number 2, this is what we have for our sounds. Moving back in our script for the player controller, here when we increase the score, we are also going to call our audio manager.instance to play the pickup sound. And here we're going to call our audio manager.instance to play the dead sound. Practically, we are done with our game. If I go back here and I'm going to pump up the volume so that we can hear the sounds. So now when we pick up our fruit, pay attention. Let me just try to pick one of these up. It's like an eating sound. You see, I had to stop there because I was about to pick up a fruit. And again. And again and again, and we can pick them up. And notice when I hit the wall, the game is stopped. We don't spawn anything anymore. We did create here a function in our gameplay controller. So we created this to cancel our spawning. We did not call it because we're using here timescale in our gameplay controller. When the timescale is set to 0, instantiate will not work. But if you want to implement something else, you can call cancel invoke. You can stop the game with the boolean, whatever you choose. And that is that basically. So in our gameplay controller, we did nothing new. We just created here our instance. We attached our pickup prefabs. I've explained how I got these values. This is the text for the score and the score count. Here we simply have a coroutine that based on the random value will either spawn a fruit or spawn a bomb. Invoke spawning, which will call this function again to start the same coroutine, increasing the score here. For our audio manager, simply playing the pickup sounds and the dead sound by using play clip at point. We created also a script to deactivate our pickups after 3 or 6 or between 3 and 6 seconds. Here for our player controller, simply we called those functions to play the sounds and to display the score. And we explained everything else in the previous videos. So again, I'm going to hit the play button so that we can see this in action one more time. So here is one of our pickups. I'm going to try to die this time by eating or touching my own tail. So I've ate this, come on, come on, come on. This and this and this, this also. Oh, I missed that one. Yeah, I died. Now you see here, you see how he died? We should have passed this here. The reason for this is because my collider for my eyeball, or this one, the dude, the snake's head, is too large. You can resize it. So the radius is set at 1, or actually for this snake, this dude right here, excuse me. So the radius is set at 0.11. You can resize it. Let me just go in the scene and search for the snake. You can resize it to something like 0.09, which is smaller. So if I hit the play button, so now our collider is smaller. We can still pick things up, so we can eat here the fruit, as you just saw. So we can eat the fruit. But when we try to pass our own tail, then it will work, because let me just try to make the snake a little bit bigger to demonstrate that. So we ate this, and let me just eat this as well. And let me try. Okay, now it worked. You see, now we are not dead by going right near our tail, but we will be dead if I do this. And bam, we have died. Again, this is our small 3D snake game. This is how simple it is. If you had this idea when the Nokia phone came out, probably we will be millionaires, but hey, we did not came with that idea first, so just learn something from this tutorial in this game that we have created. Fahir here from AwesomeDudes.com. I will see you guys in the next video.